Hello everyone, welcome to Technologies Discussion channel. Okay, before I start on today's discussion, I have some announcement to make. Okay, if you guys have followed this channel very closely, okay, you realize that I will release a video every Monday and also Thursday. Okay, because there's some changes from YouTube. Okay, so basically now YouTube allowed to have 3 minutes of YouTube short. Okay, earlier on because YouTube short is only just 1 minute. Okay, so basically I feel that it's a little bit challenge to share knowledge based on 1 minute. So hence with the new YouTube short, okay, which is under 3 minutes, therefore I have decided okay to release YouTube video every Monday and Wednesday. On Friday, then I will release a YouTube short. Okay, so basically this is a little announcement okay that I want to make. Okay, so let's continue today's discussion. Okay, today I'd like to continue the discussion on frequency synthesizer. On the part 1 series discussion, I have discussed 3 types of frequency synthesizer. The first one will be the direct analog synthesis, okay, which is what I want to concentrate on this video. Okay, so this is the first type of frequency synthesizer. The second type, which is direct digital synthesizer. And last but not least, phase loop. So basically, these are the 3 types of frequency synthesizer. Like I mentioned earlier on this video, okay, I will concentrate on the first pioneer frequency synthesizer, which is the direct analog synthesizer, which is also known as DAS. Okay, so this will be the part 2 series discussion on frequency synthesizer. So guys, if you're keen to know more about frequency synthesizer, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on frequency synthesizer. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me through the comment. Okay, before I continue, okay, I'd like to urge you guys to help me by press the like button. Just spend a few seconds to press the like button. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much. Let's quickly take a look why we need to have this frequency synthesizer. Okay, many systems okay, or many electronic devices, they actually require a clock input as a reference. And in some RF application, okay, we actually require several unique frequency that must be available quickly and with high accuracy. Okay, for example, I guess you know what is a function generator. Okay, so function generator is a electronic test equipment. Okay, for example, this is actually used to generate various types of electrical waveform, such as sine, square wave, etc. Okay, so basically the waveform also need to have a wide frequency range. Okay, although function generators can cover both audio and RF frequency, okay, but they are typically not suitable for application that demand low distortion or stable frequency signal. Okay, in such case, if we demand for low distortion and also very stable frequency signal, then we will use a signal generator. Okay, function gen are primarily used for working with analog circuit, while related pulse generator, which is digital signal, they are mainly used for, as I mentioned, for digital signal. So basically, in short, direct analog synthesizer mainly used for analog circuit, while direct digital synthesizer mainly used for digital circuit. Okay, while direct analog synthesizer, okay, at DAS method, they have been widely used, okay, for decades. But this direct digital system actually has the momentum. In fact, many years ago already, 1970, okay, this method of direct digital synthesizer basically will have more benefit. Okay, so now actually, if you want to find a little bit more information on direct analog synthesis, which is very challenging now. Okay, so nowadays, majority of the discussion will be DDS, direct digital synthesis. Okay, a direct analog synthesizer is a type of analog synthesizer that generates signal purely through analog circuit, okay, without any use of digital processing. Okay, let's do a quick overview of this key feature of direct analog synthesis. Okay, so first one will be the analog sound generation. Okay, so in short, actually, this direct analog synthesis mainly used for sound. Okay, so later on you will see. Okay, so the direct analog synthesizer actually use the analog oscillator, okay, which is the VCO, which is known as voltage control oscillator. Okay, so they actually use to generate waveform, okay, such as the sine waveform, square waveform, triangular, and sawtooth, etc. Okay, so these waveforms are then shaped using various analog components. So firstly, we generate the waveform. Okay, so basically the waveform can have any form like sine, square, triangular, or waveform. Then we need to shape the waveform, okay, using various analog components. For example, like filter, okay, which is the voltage control filter, or amplifier, which is the voltage control amplifier, and also the modulator. Okay, next will be on a continuous signal flow. Okay, so unlike digital synthesizer, okay, which rely on sample or compute data, okay, so this analog synthesizer, they are actually continuous varying voltage, which means like analog. Okay, so basically they are continuous. Okay, imagine for a digital signal, you need to rapidly change from 0 to 5 volt, for example. So therefore, there will be a so-called not realistic, not realistic. But for analog, this actually occur through the continuous changes or continuous varying voltage signal, basically to create and also shape the sound. Okay, this in fact result in a warm, rich, and organic quality that many musicians and producer actually highly value. So in short, for music, okay, because of the continuous change, because of the analog in characteristics, okay, so this actually make it very realistic, okay, which means that they are very real, and so therefore this is still highly appreciated in the music world. Okay, but most of the device that we actually work in the electronic, they actually now work in the direct digital synthesis. But over here you see that for music, then we will still continue to use this direct analog synthesis. Next, on a hands-on control, okay, you see this hands-on control here. Okay, so most of the analog synthesizer are known for their tactics to have this form of hands-on interface. Okay, so you can see that these are all hands-on interface, which means that you can adjust. Okay, so they actually featuring physical knob. So basically, these are all the physical knob. We have the slider. Okay, so these are the slider and also the patch cable. Okay, in the case of modulator synthesizer, okay, this allow us to manipulate the sound in real time. So we can do a quick changes. Okay, so imagine these are like DJ. Okay, they can do a quick changes to the music. Okay, so you need to have the direct analog synthesis in order to have this form of changes. Okay, direct interaction give user the ability to explore and shape complex sound, often leading to more creative and intrusive sound design. Okay, so basically in short, like I mentioned earlier on, this DAS, Direct Analog Synthesizer, still has the use in the music world. Okay, come to the classic circuitry. Okay, so this synthesizer rely on older technology and components such as transistor, capacitor, and also the resistor to produce the sound. Okay, the circuit involved in shaping the waveform, okay, from the filter, from the envelope, or from the low frequency oscillator, etc. They are all entirely in an analog form. Okay, lack of digital process. A key distinction is the absence of digital signal process. Okay, while some analog synthesizer may feature digital effect or sequentials, okay, the sound generation and modulation are done through analog circuitry. Okay, as I mentioned earlier on, okay, because all done through analog, okay, so the sound become much more real, and therefore this is still highly appreciated in the music world. Okay, so direct analog synthesizer which use multiplication. You can see that many form of multiplication, many form of mixing with a mixer, filtering, okay, to remove those undesired signal, okay, and also a lot of switching, and also maybe include the division, divide, okay, to generate the desired frequency. Okay, so this frequency is synthesized from either a single coherent reference. Okay, so most of the time, okay, we have this crystal as a reference, or also for multiple incoherence reference. Okay, the reference source, okay, like I mentioned earlier on, can be a single crystal oscillator. Okay, so this figure illustrates an example of direct analog synthesis approach here. So basically, you can see that, okay, as I mentioned, a lot of multiplication, okay, a lot of mixing. Okay, so you can see a lot of mixing, a lot of filtering. Okay, for example, some band pass filter to do some filtering. A lot of switching. So basically, there will be a chance to switch. A lot of filtering, and also, okay, a lot of division. Okay, so basically, division is seen over here. So basically, in short, this is how the direct analog synthesizer actually works. Okay, the advantage of this type of synthesizer is its ability to change frequency rapidly and produce a pure output spectrum. Okay, remember this is still analog, and because of this, you can call this as a pure output spectrum. Okay, similar to that of the reference source. However, this synthesizer require a large number of components, okay, including many filtering and multiplier. Okay, this actually make it very bulky and power intensive. Furthermore, the component count increase with the number of channel and the channel spacing in the system. Okay, in a wireless communication system, okay, such as GSM, just for 2G era, okay, the high number of channel and the small channel spacing actually make a direct analog synthesizer almost not possible and also undesired. So basically, that's why after GSM, remember GSM is actually an era of digital signal. And because of the digital signal, therefore the direct analog synthesizer actually phase out. So thereafter, we have this direct digital synthesizer. But over here, you can see that this is a form of direct analog synthesizer. Like you mentioned earlier on, okay, it involves many filtering, many multiplier, etc. Okay, so this can be very bulky. Okay, as you can see that, okay, so this still used in a magic world. Okay, so basically, music world, sorry. So basically, these are all the oscillator, crystal oscillator that can be as a single source of reference. A partial block diagram of a 1960 era, okay, from the HP 510 DAS type instrument illustrate the mix and divider architecture. Okay, the front panel actually allows selection of the digital, okay, for each decade of the from 30 all the way to 31 megahertz of output signal. Okay, the approximate reference signal ranging from 3 to 3.9 will route from a separate chassis to each of the mixer via a crossbar switch. Okay, so basically this is what I mean. Okay, so basically we have a choice from 3 to 3.9 megahertz. Okay, so basically we have this crossbar which is reference over here. Okay, so let me explain this. Okay, so in order to understand how this thing actually works, okay, assume the 3 megahertz is actually select at the top of the figure. Okay, so this is the 3 megahertz here. Okay, so this will produce 27 at the left hand input to the mixer. Okay, so this will give us left hand of the mixer 27. Okay, so we have 3 meg and basically 3 meg mixed together with 24. So at the output of the mixer will be 27 megahertz. So this is what it means here. Okay, so this will produce 27 megahertz at the left hand input to the mixer, following the 27 megahertz band pass filter. So basically, we have this to remove away the band pass filter here. Okay, so if the crossbar switch actually provide 3.5 gigahertz. So imagine they switch to 3.5 gigahertz here. Okay, so with 3.5 gigahertz here, okay, which means that this is 3.5. So 27 plus 3.5, okay, so it will be 30.5 megahertz, which is illustrated here. So after that, they actually went through this divide by 10. Okay, so when we actually divide by 10, this actually equals to 3.05 megahertz. So basically, this will become 3.05 megahertz. So you can see the reference is 3. So over here now, it actually changed to 3.05. And you can imagine that this thing go on and on. They basically will be so-called increase slightly, a little bit, a little bit, a little bit, etc. So as he mentioned here, this thing will go on and on. Okay, so before I continue, okay, so guys, again, appreciate that you help this channel by like this video. If you have learned something from this video, please consider to subscribe and turn on your notification bell. Let's continue. Let's come to the advantage and also the disadvantage of using this direct analog synthesis. Okay, the warmth and the richness, okay, which I have always emphasized for this video. Okay, so basically DAS is still widely used in the music world. Okay, the analog signal have nature imperfection and slightly variation that create a warmer, more dynamic sound compared to the digital method. Okay, so as I mentioned earlier on, this DAS is still widely used in the music world. Okay, because it's not perfect. You can't have a transition from 0 volt all the way to 5 volt instantly. Okay, you need to have some time. And because of this imperfection, okay, the music sound like very real. Okay, so thereafter they actually create a warmer, more dynamic sound. So therefore, the music world will be still using this DAS. Real-time control. Okay, I also mentioned this. Okay, the analog nature of the synthesizer actually allow user to directly manipulate parameters such as pitch, modulation, and also filtering. Okay, so this often led to more as impressive performance. So basically, if you have proper control, okay, if you are experienced enough to control all these parameters, then the music, okay, will be very attractive. So in short, these are all for those music creator. Okay, sound design, analog synthesizer allow for a high degree of flexibility, okay, in sound creation from basic tone to highly complex. So basically, these are all the advantage of using DAS. Coming to the disadvantage, the lack of precision, okay, which means that there's no accuracy. Okay, analog system can have drift. Okay, so you know that once you have analog, okay, even temperature can cause it to have some drifting effect. And we also have some form of instability, and also noise can be added easily. Okay, so this may not be desired in all contexts. Okay, as for the cost and the size, the analog synthesizer, especially the old types, vintage model or high quality modern ones, they are actually very expensive and they are very huge as compared to the digital counterpart. We also have limited memory and storage. Okay, as for analog synthesizer, okay, if you still remember, okay, we can slide, we can also have the knob to adjust. Typically, okay, we don't have any memory or extensive soundbar, so user must recreate setting manually. Coming to the example of the direct analog synthesizer, okay, I won't read all these three. So basically, these are all the three types of the direct analog synthesizer use case. As you can see from here, there are still many used in the music world. So basically, as I mentioned, this direct analog synthesizer still have only in use in the music world. Okay, I guess that it's very difficult to find this use in the so-called modern wireless communication. So basically, in short, this only find in the music world. Let's do a quick summary. Okay, so in summary, direct analog synthesizer, they are highly valued for their organics, hands-on approach to sound creation, produce warm, dynamic tone that remain a favorite for electronics musician and also for the sound designer. Okay, so with this, I'd like to end my discussion. Okay, please help to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you.